Hello everyone! Today we will discuss about how you can enhance your validation of the payloads to be more fluent and pragmatic. The plan is first to see how the default validation from the framework works. By default I mean validation via attributes. Afterwards we will discuss the library that became the de facto validation library that most solutions are using, aka Fluent Validation, as well as go over some specifics of that library. In this video, we'll go over how you can refactor your object that contains data attribute validations into using Fluent Validation. Small disclaimer here: if you want to build a pragmatic validation layer over one or more of your services, like for example a validation layer over an iRepository, I strongly advise you to go over to my other video, namely the one about decorators, where I show you how you can elegantly implement the validation layer using a library known as Crotter and the decorator pattern. At this moment, I should tell you, it's not imperial that you will use all the described approaches, but nevertheless you need to at least hear about them and know that you have the tools when the needs come. Okay, so first things first. For using Fluent Validation, you are going to use the Fluent Validation ASP.NET Core library that you can find on NuGet. I have it already installed. Next, you're going to go into the program.cs or startup.cs if you're on .NET Core 5 or 3.1, and basically at the part where you add your controllers or add MVC, you add one more thing, namely add Fluent Validation, and you specify from what assembly should it register the validators. In my case, I'm using the program since it's only a single API. In your case, you might register validators from multiple different assemblies. Next, let's go over and debug this solution. Basically, I have it open in this window right here. So as you can see, I have applied some basic validation rules. So if I want, for example, to send in here a number greater than 365, send an empty description or something like this, send an empty phone number, and if I try to execute this, I'll get multiple validation errors. So the description field is required, phone number is required and is not a valid one. The execution day should be between 0 and 365. Basically, the default validation is working right now, and it's validating accordingly to the data attributes that I've set up. So the main problem with the data annotation approach is the fact that at some point your class will become bigger and bigger to the point where it will be harder to maintain. This is why a lot of developers prefer to move their validation to a separate class that they can reuse and where they can focus solely on validation. As well, that class is easier to use when you set up a pipeline of middleware or a mediator behavior pipeline. We'll get to that in some other video as well. Okay, since you've seen how it works out, let's start off with our refactoring. The first step, as I said, is basically registering the validators from a specific assembly, which we are doing right now in this line of code. Next is basically creating the validator itself. So we are going to create a public class lead validator that will inherit from abstract validator, and in here we specify which class will it validate. Next, what we want to do is basically create a constructor, an empty constructor, where we will specify the rules that we are going to use. Let's start our refactoring with the description, which is the first property in our class. This one is a required string, So basically, to mark in the abstract validator that this field is required, you create a rule for, you specify that the rule is for the description, and then you specify what kind of restrictions you want to apply. So in our case, I want the restriction not to be empty. So this rule will make sure that our description is not empty. So we no longer need this required field over here. Let's debug our current solution and ensure that the description rule is applied. Small disclaimer at the first run probably is you should know that Fluent Validation integrates with the default auto-validation of the controllers that comes in .NET Core. There are some caveats, but we'll speak about that in the async part of the video. Okay, so let's try out to send an empty description over here. Basically, we remove this part. We'll get more validation errors, but at least we need to see that the description is still there. Yes. And as you can see, the description must not be empty message isn't here. This is pretty straightforward example. So yeah, the rule that we are using is not empty over a string. Next on the list is a case a little bit more interesting for beginners, since they might not know. Basically, if you specify the required data annotation over a guide, you get validation that a specific value is not a valid guide. However, this check does not check against an empty guide. What an empty guide is, it's basically something like this. So if we specify this kind of value right now, it will not trigger a validation error. And in some cases, you might need to trigger validation errors in case you get an empty guide in here. So if I try to execute this, as you can see, we don't have an empty guide validation error in here. Okay, so let's fix this behavior in our lead validator. First thing, we are going to remove the required part from here. Then we are going to specify another rule for the check ID. And basically we can reuse the same not empty rule, but for the purpose of setting up an example, if you specify a not null rule right here, this validator will behave like the required data annotation. But you can switch it up for a not empty rule, which if we debug right now and we try to resend the same payload over again, we will see that we have the description must not be empty. To enhance this a little bit more, we can as well specify right here a specific error message. I love specifying error messages right after you specify an restriction. For example, you have not empty with a specific message, you might have other not null, for example, with specific message, etc, etc. Just so you know, not empty applies not null as well. So basically, if we try to do this, let me copy a message real fast. From here, basically, we could specify a message with some placeholders for property values, property names, etc. that will get replaced at runtime. So if I run the solution again and we go over to the same tab right here, if I try to execute this, we will get the value guide empty is not allowed for check ID. Basically, these two placeholders got replaced when the validation occurred. Of course, these are not the only two placeholders that are available. You can find other placeholders over at the Fluent Validation documentation page where they go in depth. There are a bunch of other placeholders for a bunch of other validation rules, etc. that you could use in specific validation messages. Besides messages, you might also use with specific error codes or specify some severity level. I'm not really actively using the error codes and severity, but I've had cases where I needed to specify specific error codes for specific validation rules. Okay, so the next property that we are going to validate is execution duration in days, which is basically a range between 0 and 365. The value is an integer, so the rule for this property would look like something like this. Okay, sorry about that. So basically execution duration in days. We might define our roles in two different ways. So basically we could specify two different filters, greater than 0 and less than 365. For each of those we could specify a specific message, so late cannot take less than a day, let's say so. And in here with message, late cannot span for more than a year. If we use this kind of validator, and then we can remove this part right here, basically to make it look more human readable. If we try to debug this and we go over to the leads, we specify an execution in days. Basically, if we leave it at 0, we'll get the lead cannot take less than a day, and if we try to specify 370 over here, we get a message that lead cannot span for more than a year. Why I said that we could define two different rules for this property is basically you can have something like this as well. Rule for execution days inclusively between 1 and 365. And this will apply the same rule, or you can use exclusively between 0 and 365. Sorry, here should have been 364. Basically, these rules will work as the previous one, but you lose the ability to specify specific different messages, error messages for the range. So I prefer using this kind of approach. Following up, we have a simple string, which is the name, with a max length of 100. As you might imagine, the rule for this one is pretty straightforward, so it's not empty with maximum length of 100. So basically we can remove this part and reuse this rule over for the name. Next on the list we have a string, which is basically an email address that is required. So we could specify something like this. So it's email, sorry about that, email, it's an email address which should not be empty, and we can remove the required and email address parts from here. Now onto the more interesting parts. We have here a property that will represent the phone number. Let's assume the application should validate that only accepted phone numbers are from the country known as Moldova. We can achieve that kind of validation using a simple regex over the string, but if we need to validate phone numbers in multiple places, we'll get troubles since we'll have to retype the regex in the data annotations. We can of course create our own data annotation, but in the scope of the Fluent Validation library, I'll show you how that is done using the Fluent Validation. In order not to repeat ourselves in multiple places, we can create a simple custom validator that would validate the value and this is how it would look like. So basically you would have a public static class, which is a custom validators. Next we are going to define a method, static method that would return a rule builder options of t and string. Basically the type that we are going to validate. So the name of the validator will be valid Moldavian phone, where we specify the t. We pass in this rule builder of t and string rule builder, and over here we can specify the validation. So basically you return a rule builder and set the filters as matches. Now I'll copy real fast regex for the phone number of Moldova, basically, which is this one, and then you can specify message that you are going to use. In our case, property name should be a valid phone from Moldova with this specific regex in here. Now that we have this custom validator in place, we can specify that we have a rule for x.phone number, where the phone number should be a valid Moldavian phone. Let's test this out real quick. So basically I run debug for the solution and go over, try it out, and let's try a phone number that's valid for Moldova. Okay, so as you can see, the phone number is valid for Moldova. Let me try another country's code, so 400, and if I try to execute this, phone number should be a valid phone number for Moldova. Okay, so we have a custom validator. Let me move it to a separate file real fast. Okay, the next property that we are going to validate is our list of comments. And the first thing that I want to go over is basically how you apply the same filter over a list strings. So for that one, we will be using a rule for each, where we specify that each comment must be not empty. Let me run this real quick and let's go over to our leads API. So over here we have comments. If I try to send in an empty comment, I should get a comments must not be empty. So yeah, this one is working out. Now let's take it a step further. Let's assume that we want to allow only adequate comments into our model. Then we need to find out all the comments that are not appropriate. For example, all comments that contain the word bastard, which is a swear word. For this, we'll need to inject into our validator a service that will analyze specific string values. Luckily, we can inject such a kind of service into our validator quite easily. Of course, this is just a POC service at the moment. So let me stop this one real quick. Next, what we want to do is basically inject in here private read-only human reaction analyzer service specified from the constructor. Next, we can go over to our custom validators and specify another custom validator that we are going to use. So public static rule builder options t string positive comment of t, this rule builder of t and string rule builder, and over here we can specify that we need as well a human reaction analyzer service, reaction analyzer, that we are going to use in our positive comment filter. So we return our rule builder, we specify that the rule must. Here we can send a lambda expression where we trigger the reaction analyzer, we analyze the comment, basically x, and check that it should be positive with a specific message. So basically what this rule will do is check if the reaction, if the comment is positive, it will not trigger the error. If it's negative, it will return us this error message for the comment. So now we are going back to our lead validator. So for each comment, I as well want to make it a positive comment. And then here you can see that it requires the analyzer, which I basically can provide. Yeah, one more thing. I made here a mistake. We can remove it and make it just injectable into the constructor. Basically, we don't need to define a private read-only field in there. So I could use it in this fashion right here. Let's go over to the API itself and let's type in here. Basically, it should trigger, so yeah, following comment was not rated as positive feedback, and we get the message itself. So basically, you can see that we can inject services, external services, into our own validators that will help us make it more pragmatic in the long run. Next up for our video, over here we have an address, which is another object. So basically we need to validate the address itself. However, the address might have its own validation rules defined over here. So right now it's just empty strings with no validation, but we can create an abstract validator for the address and apply it when we are checking if the lead is valid. How we do that? We go over to address class. Over here we will create an address validator, which is basically an abstract validator of address. And then in the constructor we can specify some rules. For example, rule for unstructured address, not empty. We go over back to our lead validator, and over here we specify that rule for we can set a validator where we specify that I want a new address validator for it. This way we are reusing the address validator or the address field, and we are importing the rules from it over there. So right now I can remove this here. Okay, so now that we have this in place, we can go over and test it out. So over here, if I try it out, let me specify an empty unstructured address. If I try to execute it, basically we get that unstructured address must not be empty. So the rules from the address validator have applied to the lead as well. Next over, let's get to the address validator. Here I would like to remove this rule so we could go over some more interesting ways to validate the address. As for other capabilities of Fluent Validation, we can define logical chains in our validators. For example, if our system has capabilities for getting a specific address from an unstructured string, like for example using Google APIs, like how we have it in here. So basically we have an unstructured address as a string that we can provide. We can have a validator that would ensure that we have either the unstructured string or the other properties set up in place. How we do that is basically like this. So you specify a rule for street. Let's take street for example. It should be not empty when we have a string dot is null or empty x dot unstructured address. What this will do is basically ensure that the street has a value when the unstructured address doesn't have one. There are as well logical opposites to when, basically the unless, which is something like this. So the street not empty unless unstructured address is not empty. But I prefer using when. Besides that, we have another capability, namely dependent rules. By default, all rules in Fluent Validation are separate and cannot influence one another. This is intentional and necessary for asynchronous validation to work. But in cases like this, you might need a specific rule to run only after another one has finished. For example, if we want to check out the street only if the city has been filled in. To achieve something like that, we can have a structure like this, rule for x.street, not empty, then you would specify over here that it depends on the rules, and in here we can create a structure like this. So rule 4 x dot city dot empty. So basically this rule will be triggered only if the rule for city will pass. To be honest, I have rarely seen these dependent rules being used at all. Mostly developers use when and even less unless, but there might be cases when in order to validate an object, you might need to call an external service, and you want to limit the calls to that external service in case one of your properties is invalid. So, for example, like the Google API for determining that geographical coordinates based on city, address, and street are within some allowed range, you'd probably first validate that you have all the values for the city, street, and address before trying to call the external API, which might cost you money. One more thing that you should know is the fact that Fluent Validation offers asynchronous capabilities for your validators for cases when you need to call external services. Like, for example, our positive comment right here. Basically, what we could have done if the service was external, we could run a rule for each comments. So in here, we could make use of must async instead of the simple synchronous must that we have used in the positive comment custom validator. So in here we can run an async, specify that we need a comment and then a cancellation token. Sorry about that delay in there, and then we could run, comment, and in here we could have our analyzer, analyze comment async, we send in the comment, we send in the cancellation token, for result equals await analyzer. So we return analyzer is, result is positive in here, and this will have a similar effect to the positive comment checker. The only thing is that this will work asynchronously. Okay, so now I should tell you two more things about async validation. First one, you should not use asynchronous rules when using automatic validation with ASP.NET's validation pipeline, like how we are doing right now. So this one is not really a good approach to use since I'm using the automatic validation over here. This is why initially I created a synchronous positive comment validator. Why is that? Basically, if you use asynchronous rules with ASP.NET automatic validation, they will always be run synchronously, since that one is running synchronously, and you should pay great attention to that part. The next part is about how you will be using the lead validator outside of the default pipeline. So basically, if we go over to the controller method, we can specify that we want a lead validator, which is basically a new lead validator over here. We will need as well a private read-only human reaction analyzer over here, which we will pass into the lead validator. So the rule revolves around how you are using the lead validator class in here. So if the validator contains asynchronous conditions, it's important that we always call the validate async method over here when we send over the model for validation. If we will call the validate like this one, all the rules will be checked synchronously, which is not really desirable. Since we've got that out of the way, let's try and write some tests for our leads, which is basically right here. Okay, so in the meanwhile, I've split up the address models and the lead model from the validator. so they look like this right now. Basically just clean it up. Next, what we are going to do is basically go over to unit tests, and over here I'll just go over some tips as how to test your validators. So for that we'll go over and create a small address. So address is equal new address. For it we'll create a validator, which will be a new address validator. So right here, what I want to achieve is basically create a validator that will validate that either the unstructured address is filled in or the city and the street are filled in. So for that, I'll add one more rule for the unstructured address, not empty when string is null or empty x.city or string is null or empty x.street. So basically, if either the city or the street are empty, we will hit a validation error that the unstructured address should be filled in as well. Okay, so let's try it out. So in here we can have the city as test value, street as test street. We have the validator, and now we can create a validation result, which will basically be the validator test validate. This is an extension method that we could use in our tests, and in here I could specify the address. From our validation rules, we can expect that we will not have any errors for the unstructured address. So validation errors should not have validation error for x.unstructured address. And if we run this unit test, it passed successfully. Now, if I specify in here an empty street, it should fail. As you can see, unstructured address must not be empty. Okay, the official documentation is advising us to treat validators as black boxes, basically how we did it right here. Provide input into them and then assert whether the validation results are correct or incorrect. You can use the test validate and the other test validate async extension method to invoke a validator for testing purpose and then perform assertions like how we did over here against the result. This makes it easier to write tests. There are as well other extension methods like only. For example, over here, that validation should have validation error for unstructured address, and then you want to specify that it's only for the unstructured address that it has validation error. Basically, if the street is filled in, it should not have, which is not really the case since we have one more validation or error over here, like street must not be empty. And on that note, I'll say thank you for your patience and for sticking up with me until this point.